Hi, everyone. Welcome to PyData Global. We're excited to have you join us. Feel free to use the chat to connect with fellow attendees and to share your thoughts during the session. And if you have any questions, please post them in the Q&A tab, and we'll address them at the end of the session. But now it's my pleasure to introduce Ryan Varley. He is presenting his talk on Let's Get You Started with Asynchronous Programming. Ryan is the SVP of Technology at Boclips, which is an educational tech company that enables the use of video education. So let's give a warm welcome to Ryan.
Yeah, thank you very much. As said, my name is Ryan Varley. You can find me on LinkedIn with the QR code on the left and on the right. These slides will be available on Substacks following this presentation. I'll share these again at the end, so don't worry about it too much. So let's talk about what we're going to be talking about. My assumption is that you have used Python, but you've not used async, or at least you've not used it much. My aim is that you leave here with a basic understanding and actually write some asynchronous code. As a warning, asynchronous is a tool. Not everything is a nil. So it doesn't apply to everything. It's to be used when you need to use it, and it's a very useful tool to have, but you won't be using it like every day. So why is it confusing? Well, I want to acknowledge this because I found it confusing for the longest time. Like, it is confusing. The paradigm is different. There are many different frameworks. It's changed throughout Python 3. It behaves differently in different environments, and we'll get to that in a second. And when you try and talk about it and learn it, there's just so many rabbit holes you fall down. And like, this is already the third asterisk on this slide. And you just keep falling down these rabbit holes. So what I want to do is just assume everything I say has an asterisk. We're going to try and keep this talk as simple as possible. There's pretty much a caveat or but actually you can do this, or maybe you should do that for everything. But let's just assume everything has an asterisk. That keeps me happy. It should keep you happy because it should be simple. So we're going to just go over a few basics, and then we'll get straight into the asynchronous stuff. So what is I/O? It's generally network calls. So it's actually API requests, which is network, saving files, which for most people these days is saving it to the cloud or another machine. So it's network. It could be saving to local disk, but saving to local disk is so fast that like it maxes the write out anyway. So unless you're wanting to use the computation side, then it's something else. And database requests, but how often is the database on the same machine? It's network again. So generally we're waiting for network. On just a quick note on databases, it's not actually well supported by a lot of database libraries. There are some that support it, but this is not a talk on databases, and this will be a common catchphrase for the rest of the talk. So we're going to focus on async I/O. It's been part of the standard library since 3.4. It's here to stay. There are alternatives. We're not going to discuss them. There's some older ones here. There's some more modern ones. There's some even more modern ones. But we're not going to discuss them. It's too complicated. You can explore these after the talk if you want to. Everything that I've written here, I've done in Python 3.12. It should work in 3.7 onwards. It'll mostly work in 3.5 onwards. I haven't checked it. So it's just a check. So what does asynchronous stuff actually do? Well, it lets us do other things while we wait for I/O. And what do we want to do while we wait for I/O? Generally more I/O. We're doing more I/O. So for example, if we want to make 20 API calls where each one takes 1 second, if we did that synchronously, one after the other, make the call, wait for it, get the response back, it would take 20 seconds because we have to do it back to back. If we did it asynchronously, as long as the server that we're requesting from can handle it, it should take about 1 second because we do them all at the same time. So if we just sort of examine that a little bit more, if we're doing something synchronous, we have a task. The task is the majority of the task is I/O. The task takes 3 seconds. We do it on one core. It's going to take 12 seconds to do it synchronously. We do one after the other. If we use multi-processing, where we can use multiple cores, we split it up into jobs. In this case, I've split it up into 2 jobs and 2 cores. We can run those tasks back to back. So it'll take 6 seconds for the task. And then there's some overhead to doing that. So let's say 7 seconds. I've made the times up. The times that are exaggerated, so I don't have to say things like 6.1 seconds. Just be aware of that. Multi-threading is where it gets interesting because multi-threading actually behaves very similarly to async. In in that it's running on one core, but it allows you to run multiple things at the same time. So what happens is if you're running a CPU-bound process with multi-threading, we'll switch between the different tasks so that all the tasks will run at the same time. But because you're maxing out the CPU, they'll generally all finish. They'll still take 12 seconds if it's not IO bound. But if it is IO bound, you can release to another task. So it happens very similar to async, as we'll see next. But task one starts, the IO starts, we can start another task. IO starts, we can start another task. I'm saying it generally takes 4 seconds because there's a bit of inefficiency. It's going to be much closer to 3, probably like 3.2 or something. So then asynchronous, very similar. We start one task. As soon as the IO hits, we start another task. As soon as the IO hits, we start another task. And then when the IO is finished, we return to the task and continue where we were. So we'll show that as a bit more of an example. That's the sort of the difference between the 4. Well, let's write one. So this is a synchronous code. This is how we would normally make a request to an API. We're using the requests library. There shouldn't be anything too complicated in here. We're getting the video, the data for a video. We're hitting an API with the get, with the video ID. We raise if there's an error, an exception if there's an error. We turn it into JSON, we get the video. You run this, you get some JSON that has the data of the video that I just requested. Let's write it asynchronously. So the first thing you'll notice is we're not using requests, we're using something else, AI or HTTP. This is an asynchronous library, requests is not. You'll also notice that we've defined the function with async. There's also this weird thing here. So generally you have to start a session. This looks a bit weird because we've got nested async with being obviously a context manager that we'd use synchronously. Generally you would reuse it, and you'll see that later on. So you'd use the same session for multiple requests. We've only got one here. And then we've got another async with. There is just a lot of context managers when you're using asynchronous stuff because you're generally using a lot of resources. So you want to make sure they're released correctly so you don't run into errors. So generally things have context managers. The last thing that's different really is that we await the response, because there is the result of response.json is a coroutine, which we'll see next. So we have to await it. Well, then it's fairly similar. So the big thing that happens is, though, when we run this function, we get a coroutine. And I feel like coroutines are where people often start when they read about async, and then they got confused about what they are, and then they just give up. So all a coroutine is really, it's a special function that we paused and resumed. And the only thing that I really want you to remember is async def defines a function that returns a coroutine instead of the return value. So that coroutine is lazy. It must be awaited to get the return value. That's all you need to really like. What is a coroutine? It's the result of async, and I need to do of an async def, and I need to do something with it to get the return value. So just try and take that one away from about coroutines. So how do we run the coroutine? Well, if it just ran straight away, it would be like the synchronous version, right? It wouldn't be asynchronous. So what we have to do is await it. So like in this statement here, video equals await, and then the function. One thing to be aware of is await blocks subsequent code in the same coroutine. So if you stack them together, like I've done in the second block, video will run, and when video is finished, then channel will run. And that's desirable because look, channel uses video, so we need it. And there's no magic here. Like Python isn't going, oh, well, I can see that you're using the channel. You need the video to run the channel. You as the programmer have to, defining the logic. And when you use await like this, you're saying run this one first and then run this one. Other coroutines can run, and we'll show that later. But in this coroutine, there's one thing that we've defined, it will block. So how do we run this? Well, if we run this code in the Python REPL, if you type Python into the command line and it pops up, you will get this await outside function. And I think this is where a lot of people get put off. If you run this in IPython or Jupyter, however, you will get the answer. It will work. And the reason for that is they get started in a special mode that starts the event loop and makes asynchronous code work. And you can do that in the Python REPL as well. You just need to start it with this, the Python async. I can see a question, but it's like blocking the screen. Yeah, I'll answer questions at the end. So we've got Python -m async.io. If you are using Fast API, you can await in the endpoint. So you just define async def instead of def, and then you can use your async as normal. Uh, I'll cover this a little bit later, but we're not really going to talk about a Fast API, but it's just helpful if you already know Fast API. And lastly, if you try and run it in script or PyTest, you will also get this await outside function. And the reason for this is in a script, like we need to start the event loop ourselves. So we use this async IO run, and then you put in your top level entry function. So it looks something like this. I've defined this function main kind of just by convention, generally because you'll want to put a load of asynchronous stuff in there rather than just run literally one thing. And that's a pattern again you'll see later. And then at the end, you've got the if name equals main, just so that if we run the file, it'll run the code. So if we do this and we run it, we'll get our answer. Just as a little sort of asterisk, if you do run this in Jupyter, the async.io.run, you will get an error because you can't call another event loop from the event loop. You just need to await it instead. You don't need to do this if you're already in an environment like that. And part of the reason, like you'll hear, if it's async, it needs to be async all the way. So like if you think about that function we just write, it was synchronous, then we hit async.io.run. Now it's asynchronous. When that finishes, your code is synchronous again. If you want to do it again, you can. And the reason people say that is because everything within the async section has to be async, or there's kind of no point, because anything that's synchronous in there will start blocking the asynchronous stuff. Again, we'll see that when we get to an example. So the very simplest entry point, if you want to get started with asynchronous stuff, if you are already using Fast API, convert some endpoints to be asynchronous. It'll work. Your tests will work the same way as the normal tests work. If you're using Jupyter, next time you write some requests, try the async version, like we've already covered, and we'll do an example of that in a second as well, where we'll actually do a few more requests. But just to kind of like summarize that section, like await will run the coroutine if in the REPL you start it like that. In IPython and Jupyter, it'll just work. In Fast API, if you define the A point with async def. With PyTest, we didn't cover it, but you just need to use a plugin. So there's these two plugins, PyTest Async IO and any IO. There might be more. And then you just have to mark your test with that function. The docs are super simple on it. You'll find that quite easily if you're familiar with PyTest. And with a script, we need to call async.io.run to run the top level function. So let's now actually do some actual asynchronous stuff, because we ran one function, but one's nothing. We need to run more. So to do this, there's another function. It's called .gather. This groups a list of awaitables into one awaitable and then runs them concurrently. So if you remember, I said await blocks. But if you just define the functions, don't await them, and then pass them all into gather at the same time, that will then run them all concurrently. So if we modify our code to be like this, you'll see that we're now passing the session in. Remember, I said we'd use the session, so we're not defining a new session every time we want to do a call. We've also added this connector. So this is just a config for the session that allows you to limit. So if we just run this off the bat, we would send 100 requests all at the same time, and we'd probably overwhelm whatever API that we're using. So this limit per host setting just lets you limit it to 10 or whatever number you want. The limit is the number of connections across all hosts. That is by default 100, but I included it so you can see it. Then just above, we've got the tasks. So we're actually just using a normal list comprehension to set up our coroutine. So the get video async for every video in video IDs. I've defined video IDs elsewhere. It's just a list of 100 IDs. And then we gather them. So the only gotcha there is gather doesn't accept a list. It accepts like a series of arguments. So you just need to use the asterisk to expand it. And finally, we just await that one function and we'll get it all. So if we do this, to get one video, it took 0.2 seconds. To run 100 without that limit of 10, it took between 2.1 and 12 seconds when I ran it multiple times. And that is because we were overwhelming the server, and the server was starting to slow down, and it ended up taking too long. And when I put the limit of 10, this server actually was more comfortable with that, and we got a range of 1.8 to 2.7. We do a maximum of 10 at a time. So it's just always worth bearing that in mind. But I think we should need to do something just a little bit more complicated. There's one thing just running a lot of requests, but let's actually write a proper service. So I think like a lot of the people here, and I guess my background as well, is like our data scientists or work on data teams. So we're going to write a service called the content warning service. So this at Bowclips, we have a library of videos, and we want to assign things to those videos, like if there's any profanity in them, or if it mentions war, stuff like that, that our users might want to be aware of. So we're going to build a model to do that, and then we're going to use Asynchronous to sort of write this service. Because I don't really want to write profanity models and all that stuff, our model is actually just going to be an is NASA model. And we'll see that later. So in order to do this, we need to get the video data. We need to get the transcript, because when we make that video call, the way that this API is designed, it doesn't have the transcript. We need to make a separate call to get that. We then need to run our content warnings model. And then we need to update the video. So we need to hit that video endpoint again and tell it to update the video with the content warnings that we've just generated. So these three things, 1, 2, and 4, all hit the video service. That's 3 lots of requests. And then the model runs in this service. So let's do it. And this didn't take me too long to write. Like once you've like got the concepts, I think it's actually quite easy. But there's a few things to get here. So the first function here, get video, is exactly the same as the get video function that you saw before. And then I've just written another one that gets the transcript. So the only real difference between them is the transcript hits a different endpoint, and it has to handle the response slightly differently. I'm then going to write my model function. So rather than actually importing a model, I've just written a line there, that hashlib, that's just simulates compute. So that's just a complicated computation function that's going to take about 1 second to run on my machine. I'm going to do that 10 times. Well, it's going to take 10 times, it'll take 1 second. And then the actual model, I'm just going to look for NASA in the text. This is the input to the function. So like, obviously you'd replace this with maybe something you found on Hugging Face or something you developed. But this just keeps things simple for this demonstration. So then we need to actually sort of link all of that together. So in this function, it's a bit smaller, so I hope you can see it. But we're first of all going to get the video. So video is await the get video function. We're then going to get the transcripts, which we have to await the transcript function. The text, I'm just going to join all that text together to feed into the model. This warning IDs is assuming that we're going to add multiple models. It's not just going to be is NASA. We might also do, like is the UK Space Agency or something like that as well. We're going to get that list of warning IDs, and then we're going to save them to the API. And this function, this save video content warnings, I haven't shown you, but it's exactly the same as get video and get video transcript, except it's a patch and just passes some data in. And then to link it all together, so that just generates content warnings for one video. We need to do it for multiple. So we're going to set up our session like before. We're going to set up our tasks like before by doing a loop over all the video IDs. And then we're going to gather those tasks, and then we're going to run them. Now, if anyone's keen-eyed among you, you might have noticed I've maybe made some mistakes in here. We will cover them afterwards, but let's run this. So just before we run the first one, the way I've set this up is so that it logs when the IO has started for each one and logs when it finishes. So you'll see red for when it gets the video, blue for when it gets the transcript, and that's in the second column. The third column in green is run the model, and then the yellow column and the fourth one is saving the result. So if we run this synchronously, we will just see get model, get video, finished getting video, get transcript, finished getting transcript. And it'll just follow down, and then we'll do the next one. The other thing I've done is convert all the video IDs to words. So the words inflate, imagine, panel are just video IDs that I made it so that you can actually tell what's going on. So the synchronous version that I haven't shown you, but it took 3 minutes, 20 seconds to do this for 100 videos. So let's run our asynchronous version. So a few things happened there. So I'm going to sort of explain them, and then we'll run it again. So the first thing that happened was all of our video calls ran at the same time, that red first column. Then we started seeing some of our other ones go. So if we do it again, watch for all the red. And then we started to see the blues come thing. And if you look at that, it says finished video driver, get transcript driver. So clearly it's blocking. It's not getting the transcript until we finish the video. So we've made a mistake there. The second thing that you might have noticed is when the model starts running, nothing else is running. So it's taking quite a lot of time, and you've got, run model ankle, saving result, run model printer, finish printer. So nothing's happened when we started the run and finished the run, and that takes a second. And that's because we're blocking that call. So that's another mistake that we've made. The third thing is you saw so many video calls at the beginning. I didn't do any limit, so we just triggered all of our video calls at the beginning without actually limiting anything. So let's solve all those three problems. This version, by the way, took 1 minute, 22 seconds. So we've got an improvement, but we made some mistakes. So yeah, we're overwhelming the API. So we need to add a limit per host. You've seen this before. We put into the session with the sort of green bar demonstrating what the new code is. We put a limit per host of 10. But let's do something else for a few reasons. One, I want to show you something else. Two, the transcripts endpoint can actually handle more requests at a time than the videos endpoint can. And three, the way that I've set up that logging actually doesn't work well if I use this session, because the way that the session actually blocks. So you'll see all of the functions trigger, but it's not actually correct. So for those three reasons, we'll do something else. So let's use a semaphore. So a semaphore is just a counter, but if you await with it, it'll basically just block anything happening over the limit. So the two lines that I've added at the top is a semaphore 5 for video and a semaphore 10 for the transcript. That means only 5 video requests can happen at a time, and only 10 transcript requests can happen at a time. And all I've done to the functions is add that async with the video semaphore to implement that. The second thing, which you might have noticed because I covered it earlier, is we're blocking, because we've done that video await, get video, transcript await, get video on the left, where that's marked with the red. On the right, we just need to change this. So we know how to run 2 coroutines at the same time. We need to use async.io.gather. So we set up the tasks without awaiting them on the right. That was highlighted with the green. And then we do async.io.gather both of those tasks together. The very last thing is the model is blocking. So when that result equals is NASA model goes, that's synchronous code. It's 1 second. When that's happening, no other coroutines can run. Anything that's already running IO can still happen, but no other coroutines will trigger until it's done. So the way we get around this is there's this loop.runIn executor function. So we need to get the loop, which is the running event loop, with this async.io.running loop function that's on the right, highlighted with the green. And then we do the running executor function. And that just takes in the thread that you're using, which I've put as none. It takes in the function, which is NASA, and then it takes in the argument to that function, which is the text and the video ID. Now, this is an asterisk I did want to talk about, because technically when you use none, it runs in a thread. It can still block, because if it's maximizing the CPU and we're running lots of them, they're not going to run any quicker. But the main reason I wanted to do this was so that other coroutines can run. And my function isn't actually blocking other coroutines running if it's in a thread, because it can switch between them. Yours might, you can look for it. If you want to get around with that, you can actually use this process pool executor on the bottom. That is multiprocessing though, and comes with the same pitfalls as multiprocessing. So you might end up with like pickle errors and can't like reuse the same things. But you will be able to split your job across multiple cores if you want to. I'm not going to do that. I'm just going to do the first thing. So let's run it. So now you can see like there's red, blue, green, everything happened at the same time. The blue's finished because I told you that the transcript call was really fast and can handle a lot of traffic. That got done straight away. We're still seeing reds, we're still seeing greens, lots of greens happening at the same time, lots of yellows happening as well. And you just saw the whole function finish. I didn't show you the others because they were too slow. We just saw it. It took 13 seconds to do all of that. And if, as a reminder, the first attempt took 1 minute, 22 seconds, and the synchronous version took 3 minutes, 26 seconds. So let's just show you again. Just remember, like this time, look for the blue at the top, because remember the transcripts finished quickly, and I've done a limit of 10 on them. So there's the blue in the second column. They're all done pretty much straight away. And now we've got models running. We've got request sender saving stuff to databasing. We're still requesting video transcripts with the red. And at the end, we've run out of video transcripts now. The models are finished. All of the database recalls are finished. So that's it. I mean, do you feel ready to use async? I hope you do. If you went away and used async for the first time, please let me know. If you have feedback on this talk, something you didn't understand or you thought was quite good, let me know. You can find me on LinkedIn. The slides will be available on Substack on the right shortly after this talk. And just thank you.
Thank you, Ryan. I believe we just had a question in the box, a couple. So someone wanted to know, is a coroutine like a promise in JavaScript?
I'm not a JavaScript developer, but I believe a promise is something that will actually return on itself eventually. So it's like a promise that it will happen. But yeah, I'm not a JavaScript developer, so I'm not 100%. I think it is slightly different.
And I'm going to ask another question. It says, which framework between the Django, Flask, and Fast API is inherently asynchronous? Which framework do you recommend and why?
I believe they all sort of naturally do an element of asynchronous stuff because they can, but they do it through threading out the box. The one that I'd recommend is Fast API because I think it's the easiest to use. I think it's also works very well with asynchronous stuff. So if you just write normal def functions in Fast API, it can run multiple at the same time because it'll just thread them. But you can get performance benefits, and especially if you're making multiple calls within an endpoint, like that example I did with the video and the channel, or the video and the transcript, you will get benefits there. So I would personally, all of them should be able to do it. All of them do a bit of it anyway, at least do concurrency anyway. But I'd recommend Fast API.
Thank you. And we have a couple more. How could one employ async with pricing data to trigger tasks or jobs or coroutines, such as in a crypto application?
I'm guessing, I don't know exactly what you'd want to do here. I'm guessing you'd be making lots of network calls to like fetch price data or something. It's really, you want to benchmark your function to see if there's a benefit to doing this. It's really obvious there's a benefit if you're running lots of synchronous requests. So that's when you might want to use async. If you're not sure, just like I guess the standard premature optimization is the root of all evil, you should benchmark it to see if there is actually a problem with asynchronous stuff. And there is other resources to do that. One of them is High Performance Python, which is an O'Reilly book.
Thank you. And are there any tips or tricks you can recommend to remember which of the async approaches to use for a situation?
So there isn't that many. Like there is more stuff you can do with async, but if what I've covered today, if you review the slides, like I don't think there is that much that you have to remember. The main thing is that slide that I put on, like, will it work in different situations? So like, are you in a notebook, like a Jupyter notebook, in which case you can just await stuff. You can just do what I did there. If you're not and you're in a script, then you just need to run the loop. The other concepts are just things like the semaphore for like limiting resources and stuff like that. And that will come with time. Like I tried to build these slides and the slides will be on that Substack link. I'll also put the code on that Substack link, but it'll take a few days for me to do that because I just need to clean it up a little bit. So you'll be able to review it. Part of it is just going to be learning, like implementing it for the first time, hitting the problems, realizing you've overwhelmed the server. Hopefully I've planted in your head that you can solve that with either the limits or a semaphore. And again, hopefully if you encounter a problem like the model's overrunning, like running too long and blocking, it'll go in your head and you'll remember to review it. So I've tried to plant a few things that you can refer back to.
Thank you so much, Ryan. And thank you everyone for joining us. We are currently at the end of our session. A recording of this session will be available shortly for rewatching. And for those interested in more casual conversations, feel free to join the lounge. In the reception area, you can get in small groups. So we'll see you there and enjoy the remaining sessions. Thank you again, Ryan.
Thank you.
Bye-bye, everyone.